Okay, so today, guys, we are going to be playing U.S. Army Stars Elements, um, which is available on the App Store for both iPad and for Android, Google Play. It also has a web player feature, um, but we're going to be downloading it from the App Store. If you just type in U.S. Army Stars Elements, you should be able to pull it up. Of course, I've already got mine downloaded, so I've opened, but you'll have a download button there. Um, so we're going to pause the video so you can download it, and we will be learning about the Octet Rule. Okay, so once you've finished your download, click on the Smashbond button, which is the fourth button down. It's going to make a little bloop noise and open. So the octet rule states that you want to fulfill 8 electrons, oct meaning 8, in the outermost valence shell of an atom. And that is because all atoms want to be as close to a noble gas configuration as possible. They all want to be kings and queens in their own right. They all want to be noble gases, remembering that noble gases have 8 electrons in their valence shell, with the exception being helium. Okay, the game has started. So what's going to happen is I'm going to take gallium and sulfur and swap them on the screen. You'll notice that they are not going to add up to 8, but it will let me move the tiles around. So the key difference here with the U.S. Army Stars Elements Smashbond game is that unlike Bejeweled, where you're only allowed to make matches, you can actually rearrange the tiles to create matches as needed. However, one thing that you want to keep in mind is that you only have a limited number of moves here. So we have 10 moves. So there I go, down to 9. And then I'm going to swap it back, the sulfur and the gallium. So in level 1, you only have 10 moves to fill up this bar. Okay? There we go. I only have 8, and I've still created nothing. So we need to be thoughtful and strategic about moving the tiles around. There's 3 different covalent compounds which can give you a bonus on the left-hand side of the screen. Well, let's go ahead and look at carbon disulfide. Okay, so carbon disulfide has a chemical formula of CS2, and the Lewis dot structure is the structure that you see here on the screen with the 2 dots at the top, the 2 dots at the bottom, and then each line represents 2 of these dots. These dots are electrons. And remember, oct meaning 8. We're trying to fulfill the octet rule. So if we count 2, 4, remember a line is 2 electrons as well. So 2, 4, 6, 8. There are 8 electrons then that are associated with sulfur. 2, 4, 6, 8. There are 8 electrons that are associated with carbon. 2, 4, 6, 8. There are now 8 electrons that are associated with this sulfur. So this is a covalent compound. And if you had been looking at the tiles at the time that they were swapped together, you would notice that they were both green. Because all of the metal tiles are teal and all of the non-metal tiles are green. And so the chemical name is carbon disulfide. This is the Lewis dot structure, or the chemical structure. This is the category of the compound. It's covalent. So you're going to be forming both covalent and ionic compounds here. Let's go back to the main screen. I'm going to show you a little bit more about these bonus features. Again, they're all covalent compounds. We have hydrogen, sulfur, and a hydrogen again. So hydrogen sulfide. One might say it should say dihydrogen sulfide, actually. These things happen. So we have arsenic trichloride, 1, 2, 3. Tri, meaning 3. Chloride, remember you take the INE and replace it with IDE. And we have arsenic. And the first name always remains the same if it's a mono, right? If we have one, you can't say mono arsenic. You have to say arsenic. Mono never goes on the first word of a compound, ever. It can go on the second or the third to infinity and beyond, like Buzz Lightyear, but never on the first, okay? So, here we are, arsenic trichloride, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All of these compounds have the octet rule fulfilled. Boron arsenide. Again, I would say it should say boron mono arsenide, in fact. But again, that's one of those trivial things. The main thing that I really like about this game is that we have the octet rule and that they organize the tiles. There we go. There's an ionic compound. Notice that the teal and the green tile came together. Lithium fluoride. Now that's a correct name. The first name always remains the same, and the second one just gets an IDE on the end, and you remove the last vowel and everything that follows it. So it was fluorine. It was INE was replaced with IDE. Even though there's not 8 electrons on the lithium itself, because it's an ionic compound, and in ionic compounds electrons are transferred, it's associated by static charge here. This is a +1, and this is a -1 charge. And that's because this is a group 1A element, and this is a group 7A element. 7 + 1 is 8. The protons in the middle of this guy here exceed the electrons, so that's why it's a +1, because 1 electron left. All of these lines mean that 1 electron belongs to something on the left and 1 electron belongs to something on the right.